Hi guys, welcome to a new video on differentiation, paper 2 questions under math studies. This video deals with questions of a level 3 difficulty, so this is an intermediate level of difficulty. I shall deal with the two questions on the screen in front of you, and I shall begin the first question shortly. I shall now attempt to solve May 2018 time zone 1 question 4. Kindly take a minute and attempt to solve, and the answer shall follow through shortly. So you are given the graph, the function 48 over x plus kx squared minus 58, where x is greater than 0 and k is a constant. The graph of the function passes through the point with coordinates 4, 2. Find the value of k. So since we know that the graph passes through 4, 2, we know that when x is 4, y is 2. Hence, if I plug 4 instead of x in this equation and 2 instead of y, or f of x, I should be able to find k no problem. So this is what we've done. 2 instead of the y and 4 instead of each x, and we simplify, and the k turns out to be equal to 3. So using your value of k, find f dash of x. So I've rewritten this function here in green right there, substituting the k for 3 and taking the x from the denominator to the numerator and writing it as x to the power of -1. So I have not differentiated yet, but I've just rewritten the function in a nicer form. Now the red expression is the derivative of the green expression, or the derivative of my original function, and there is your answer. Next, I'm told that P is the minimum point of the graph of f of x. Use your answer to be to show that the minimum value of f of x is -22. So the minimum point exists where f dash of x equals 0, so I have to set f dash of x to 0 and find the value of x, and then use this value of x to find the value of f of x by plugging the x value into the original equation, and the answer should be -22. So f dash of x equals 0. I'm going to set this expression to 0, and I'm going to do some simplification and then solve for x, and x equals 2. So if you plug 2 into the original function, either using the GDC, you can use the GDC in this part, but you had to arrive at the value of x manually. So let's type the equation down and find f of 2. So I've written down the equation on the GDC the same way it was written in the question, except for the fact that I've substituted k with 3, and I've adjusted my window. I've cheated and used the information given in the last question to adjust my x and y values, and there is what the graph should look like. So we are trying to find f of 2. So second trace value 2, and the calculator tells me that f of 2 is -22. Next, in question D, I'm required to write down the two values of x which satisfy f of x equals 0, and these are obtained from the GDC using what we call the zero function. So second trace 0, this is a calculator function that helps you find the zeros of a function or the x-intercepts of a function. So we can tell from the graph that there are two zeros, there and there. A zero of a function is a point where the function intersects the x-axis. So the left bound has to be somewhere to the left, obviously, of my point. The right bound has to be somewhere to the right, and I guess that the zero is there. So the first zero exists at 0.861. I repeat the process for the second zero. So there is my left bound and right bound, and guess. So my second zero exists at x equals 3.903. Hence, these are my solutions. Finally, I need to sketch the graph of y equals f of x for this domain and range, which I have used to draw my graph. These are the values I've set on my window anyway. I need to indicate the minimum point and the x-intercepts, which I've already found in C and D. I just need to indicate those on the graph. So there is the marking scheme version. So there is your marking scheme version, and there is what we have on our GDC. They kind of look the same, and they have given you 1 mark for the correct window, a mark for the smooth curve with the correct shape and the zeros in an approximately correct position, a mark for point P indicated in approximately correct position, which is the minimum value, and a mark for the two x-intercepts identified on the graph, and the curve reflecting asymptotic properties. And by asymptotic properties we mean that the curve cannot cut the y-axis, and you could infer this from the equation of the curve, 48 over x. So when x is 0, the curve is, the value of y is infinity, so the curve shall never actually cut the y-axis. There will never be an x equals 0 on the curve. This is not a part of the curve. The curve is not defined for this value of x. So anyway, these are the marking scheme requirements, and you can take another final look at the solutions to the entire problem. This concludes our question. I hope you have found it useful. We shall now attempt to solve paper 2, May 2009, time zone 2, question 5. Kindly take a minute and attempt to solve. The answer shall follow through shortly. So we are given an expression for f of x, 5 over x squared plus 3x plus c, and in A we are required to find f dash. So I've rewritten the function here in red. This format should be easier to differentiate than the original function. The change that I've made is that I've taken x squared from the denominator to the numerator, and I've changed the power to -2. So the derivative of the red function right there is given by this blue expression, -10x to the power of -3 plus 3, or -10 over x power 3 plus 3. Both formats are fine. Next, I'm given that the graph of f passes through the point P1, 4. I am asked to find the value of c. So since I know that the graph passes through this point, then I know that when x equals 1, y equals 4, or when x equals 1, f of x equals 4. So I shall simply plug 1 instead of x here and here, and plug 4 instead of the f of x. Hence 4 equals 5 over 1 squared plus 3 times 1 plus c, right there. Hence, the c shall equal negative 4. Next, I'm told that there is a local minimum at the point Q, and I am required to find the coordinates of Q. Since there are 7 marks allocated to this question, you cannot simply type the equation on the GDC and use the calculator to find the minimum. You have to do the algebra required to find the minimum. So you get a mark for realizing that a minimum point means that f dash of x equals 0, and then setting the equation of f dash equal to 0 and attempting to solve using algebra or using the GDC after you've written this equation down. Hence your x equals cubic root of 10 over 3. Next, I shall find the y coordinate using the GDC as follows. So I've written down the equation on the GDC, and there is what my graph shall look like. There is your window for reference, and there is your graph. So I can try to find the y value by second trace value, and the x shall be cubic root of 10 over 3. So this is the same as 10 over 3 to the power of 1 over 3. And the answer is 2.72. So the calculator tells me that when x is cubic root of 10 over 3 or 1.49, y equals 2.72. If you'd like, you can check your answer using the calculator function for minimum, but you cannot only depend on this function, you have to show the workout that we have just explained. So using the GDC, there is a simple function, second calc minimum left bound, right bound, and guess. And the calculator again tells you the coordinates of the minimum point, and you can use this as a way to check that your answer is correct. Next, you need to find the set of values of x for which the function is decreasing. We can tell from the graph that the function is decreasing before this point, so in this region right there, and this region extends from 0 to the minimum point, which we have found to have an x coordinate of 1.49. It's still written on the GDC right there. So from 0, bear in mind that the curve does not touch the 0, it does not touch the y-axis. So 0 is less than x, and x is less than 1.49. You cannot have less than or equal here. You cannot have less than or equal here because the curve doesn't touch the axis, and you cannot have less than or equal here because at 1.49 specifically, the function is not decreasing or increasing because there is a stationary point. So your inequality has to be a strict inequality without less than or equal. Next, you are told that t is the tangent of the graph of f at p, and you want to show that the gradient of t is -7. So the gradient of the tangent at p is the gradient when x equals 1. So I simply substitute f dash of 1. I substitute 1 instead of x in the blue equation right there in order to obtain f dash of 1. So 10 over 1, -10 over 1 plus 3, which gives me -7. Hence the gradient is -7. Since this is a show that question, you cannot use the GDC function to simply obtain the numerical slope without substituting x equals 1 into f dash of x. Next, I need to find the equation of the tangent, and the equation requires that I find the gradient or the slope, which is -7, and it requires that I have a point, which is point P, with these coordinates. So everything is already there. I simply need to use the point slope formula. And there is my answer right there. Y minus 4 equals -7 times x minus 1. Finally, I'm told that the tangent T intersects the graph again at R. Use your GDC to find the coordinates of R. So I want to find the intersection between the tangent and the graph. What I'm going to do is I'm going to draw the tangent on my GDC, but in order to do that, I need to play around with this equation a little bit to obtain another version of the equation where y is alone on one side. So y equals -7x plus 11. Bear in mind that I simply obtained this equation from the blue equation by some algebra. I expanded this bracket, so I got -7x plus 7. Y minus 4 equals -7x plus 7, so I simply took this 4 right there and moved it to the other side with a change in sign. Hence y equals -7x plus 11. So I've written the equation on the calculator. I shall click on trace, and there is my tangent line. We know that the line is a tangent at this point right there, but we are required to find the point where the tangent intersects the curve elsewhere otherwise. So we can tell that the point lies roughly somewhere here. So I shall just increase my window a little bit vertically to be able to see better. So y max shall be 25 maybe instead of 15. If I click on trace, I shall get a better image. There is your curve. There is your tangent, and we want to find the point of intersection right there. So second, trace, intersect. There is your first curve. There is your second curve. And there is your guess. So the intersection is at -0.5 and 14.5. So there is your answer. Take a minute to copy this down if you will. I hope you have found this useful.